Why German mechanics were stunned U.S. engine blocks simply dropped in. In the spring of 1945, somewhere in a bombed-out repair depot in western Germany, a German army mechanic named Wilhelm Krause pulled open the hood of a captured American truck. He had been fixing German engines for 6 years. He had worked on Opels, on Mercedes-Benz military trucks, on Kübelwagens, on the massive engines of Tiger tanks. He knew what an engine was supposed to look like. He knew how long it was supposed to take to pull one out and drop a new one in. He looked at what was in front of him. He looked for a long time. Then he called over the other men in the depot. Because what he was looking at did not make sense. The American engine, a simple, cast iron block from a standard U.S. Army truck, sat in its engine bay with a kind of mechanical cleanliness that he had never seen in a German vehicle. The mounting points were identical to the last one he had examined. The connections were in the same places. The tolerances were so consistent that you could take an engine from a truck built in Michigan in 1942 and drop it into a truck built in Ohio in 1944 and it would fit perfectly, every time. No grinding, no adjusting, no filing down a component that was just slightly too large, no searching through a parts bin for a bolt that matched because the threading was a little different from the last batch. You unbolted the old engine. You lowered the new one in. You connected it. You started it. That was it. Wilhelm Krause had spent his entire mechanical career in a system where that was not how it worked. Where every batch of parts was slightly different. Where fitting an engine was a skilled job that took time and experience and a set of hands that knew how to make things fit that weren't quite right. He stood in that depot in the spring of 1945 and understood, perhaps for the first time, something that should have been obvious. Years earlier, the Americans had not just built more trucks than Germany. They had built them differently. Fundamentally, systemically, from the ground up differently. And that difference, invisible, unglamorous, never discussed in a single wartime communiqué, had done as much to win the war as any battle. This is that story. To understand what stunned Wilhelm Krause, you have to go back about 150 years. Not to World War II. Not even to World War I. You have to go back to a rifle factory in Connecticut in the 1790s. His name was Eli Whitney. You probably know him as the man who invented the cotton gin. That is true, but it is not the invention that changed the world. What changed the world was something Whitney did in 1798, when the young United States government, terrified by the possibility of war with France, needed 10,000 muskets and needed them fast. More muskets than American craftsmen could produce in years, let alone the months the government had in mind. Whitney made the government a promise. He would deliver 10,000 muskets in 2 years. The government laughed at him. 10,000 muskets meant 10,000 individual weapons, each one made by hand, each one slightly different from every other one, each one requiring a skilled gunsmith who had spent years learning his craft. There were not enough gunsmiths in America to do that in 2 years. Whitney told them they were thinking about it wrong. He wasn't going to use skilled gunsmiths to make complete muskets. He was going to design a system where each part of the musket, the lock, the stock, the barrel, the trigger mechanism, was made to such precise and consistent specifications that unskilled workers could produce them in large quantities, and any lock from any batch would fit any musket from any batch. He called it the system of interchangeable parts. And when he demonstrated it to President John Adams and Vice President Thomas Jefferson, taking musket components from different batches, mixing them up, and assembling working weapons at random, the room went quiet. What they were watching was not just a clever manufacturing trick. They were watching the birth of what would become known, in workshops and factories and military depots across the world, as the American system of manufacturing. The idea spread slowly at first. Real interchangeability, true interchangeability, where any part from any batch would fit without adjustment, was much harder to achieve in practice than in theory. It required machine tools of extraordinary precision. It required measurement standards that everyone in the manufacturing chain agreed to and adhered to. It required a willingness to invest in expensive precision equipment up front in exchange for savings in labor and time later. For most of the 19th century, most of the world's manufacturers decided that investment wasn't worth it. The Americans disagreed. By the middle of the 1800s, American manufacturers had pushed the system of interchangeable parts into sewing machines, clocks, agricultural equipment, revolvers. The Colt revolver, the gun that won the West, as the saying goes, was built on interchangeable parts. Any cylinder from any Colt would fit any frame from any Colt. A soldier on the frontier whose revolver was damaged could cannibalize parts from another broken weapon and build one working one. European visitors to American factories in the 1850s came home and wrote reports for their governments that read, in places, almost like dispatches from another planet. The precision, the consistency, the speed, the way unskilled workers could perform tasks that in a European factory would require a craftsman with years of training. They called it, with a mixture of admiration and alarm, the American system. Germany, in particular, took note. German industry was world-class. German engineering was perhaps the finest in the world. But German manufacturing culture prized craft, prized the skilled worker who could take components that were slightly different and make them fit through experience and expertise. Prized the machinist who knew his machine so well that he could feel in his hands when a tolerance was right. That culture produced magnificent things. It produced precision instruments and excellent weapons and engineering of extraordinary sophistication. It also produced a problem that would not become visible until 1939. The problem was scale. Germany went to war in 1939 with an army that was, in many respects, the finest in the world. Excellently trained, brilliantly led, equipped with weapons that were often technically superior to what their opponents carried. The early German victories, Poland in weeks, France in 6, were genuine military achievements that left the rest of the world struggling to understand what had happened. But victory in Poland and France also consumed German equipment at a rate that the Wehrmacht's planners had not fully anticipated. Trucks broke down, engines wore out, vehicles needed parts, and here the problem began to show itself. German military vehicles in 1939 came from dozens of different manufacturers. Opel, Mercedes-Benz, Borgward, Bussing, Henschel, MAN, Krauss-Maffei. Each manufacturer used its own components, its own tolerances, its own engineering solutions. A part from an Opel Blitz truck would not fit a Mercedes-Benz truck, even if the two trucks performed essentially the same function. This was inconvenient in peacetime. In wartime, it was becoming something worse. A German repair depot in France in 1940 might be responsible for maintaining vehicles from 6 or 8 different manufacturers. Each manufacturer's vehicles needed different spare parts, different tools, mechanics who understood that manufacturer's particular engineering choices. When a vehicle broke down, you needed the right part for that specific make and model. If you didn't have it, the vehicle sat until you did. The German Army's logistics tail, the supply chain responsible for getting spare parts to the front, was carrying an enormous and growing burden of parts diversity. Tens of thousands of different part numbers for vehicles that all basically did the same thing. The Americans were watching this. They had watched it through the 1930s as Germany rearmed. And American military planners, who had spent decades building on the tradition that Eli Whitney had started, made a decision that would seem almost boring in its unspectacularity. They standardized. The man most responsible for what happened next was not a general. He was not a politician. He was not even a particularly famous figure in the history of the war. His name was William Knudsen. Knudsen was a Danish immigrant who had come to America in 1900 with almost nothing and had spent the next 4 decades working his way up through the American automobile industry until, by the late 1930s, he was the president of General Motors, the largest manufacturing company in the world. He understood American industrial capacity the way a musician understands an instrument. He knew what the factories could do. He knew how to organize production. He knew that the difference between building 100 of something and building 1,000,000 of something was not just a matter of adding more workers and more machines. It was a matter of system design, of engineering the manufacturing process itself with the same care you applied to engineering the product. In 1940, President Franklin Roosevelt called Knudsen to Washington. The military buildup was beginning. America was not yet in the war, but the direction of events was becoming clear. Roosevelt needed someone who could look at the entire American industrial base and figure out how to turn it into a war machine. He picked Knudsen, And Knudsen, within weeks of arriving in Washington, identified the single most important principle that would govern American military production for the next 5 years. Standardization. Absolute, uncompromising, built into the design process from the beginning. Standardization. American military vehicles would not come from dozens of manufacturers each doing things their own way. American military vehicles would be designed around common components, common engines, common transmissions, common axle assemblies, parts that were manufactured to tolerances so precise and so consistently maintained across the entire production chain that any part from any factory on any day would fit any vehicle of that type from any other factory on any other day. The engine block that came off the line in Detroit on a Monday would fit the truck chassis that came off the line in Cincinnati on a Thursday. Drop in, connect, start, drive, dash. This sounds simple. It was not. Achieving true interchangeability at the scale of military vehicle production in wartime required solving problems that had never been solved before at that scale. It required a measurement system, a system of gauges and standards and inspection procedures, that was applied identically at every factory in the production chain. A bolt manufactured in Michigan had to meet the same dimensional specifications as a bolt manufactured in Ohio. Not approximately the same, within thousandths of an inch. It required machine tools of extraordinary precision. American machine tool manufacturers, companies like Cincinnati Millicron, Brown & Sharp, Giddings & Lewis, spent the early war years producing gauges and cutting tools and grinding machines to tolerances that had previously only been required in scientific instrument making. It required training, tens of thousands of workers, many of them women entering industrial employment for the first time, many of them men who had never worked in a factory before, had to be taught not just how to operate a machine, but how to measure their output against a standard and reject anything that didn't meet it. And it required a willingness, on the part of manufacturers who had built their reputations on their own proprietary designs, to give up some of that proprietary identity in the service of the larger system. This last requirement was, in some ways, the hardest. American manufacturers were competitive, proud, and not naturally inclined toward the kind of collaboration that standardization demanded. Getting Ford and General Motors and Chrysler and Studebaker and all the others to agree on common component specifications required the kind of industrial diplomacy that Knudsen spent months practicing. But it worked. By 1942, the American military vehicle production system was producing trucks, jeeps, half-tracks, and armored vehicles with a degree of parts interchangeability that no other nation had ever achieved at anything approaching that scale. There is a soldier's account from the Pacific Theater, written by a U.S. Army supply sergeant named Robert Calloway, that captures what this meant in practice better than any official report. Calloway was stationed in the Solomon Islands in 1943, responsible for maintaining the motor pool of his infantry regiment. The supply lines to the islands were long and unreliable. Ships were being sunk by Japanese submarines. Parts were sometimes weeks away. He wrote in a letter home, "We had 3 trucks that were wrecked beyond saving and 2 trucks that needed the same part we couldn't get. I took the 3 wrecked ones apart and built 2 working ones. They run fine. Back home that would have been unusual. Out here it is just Tuesday. 3 wrecked trucks, becoming 2 working ones because the parts were interchangeable. Because a wheel bearing from one truck fit another truck. Because an engine from a wreck dropped into a truck that needed one." That was the American system at work. Not in a factory in Detroit. In a muddy motor pool on a Pacific island, 6,000 miles from the nearest spare parts depot. The German experience, by comparison, was becoming a nightmare. By 1942, the German army in the Soviet Union was operating with a vehicle inventory so diverse and so poorly standardized that the logistics of maintaining it had become one of the most serious problems facing the Wehrmacht. A German army report from the Eastern Front in the winter of 1941-1942, one of many such reports that went to Berlin and were largely filed away without action, listed over 2,000 different types of vehicles in service with Army Group Center alone. 2,000 types, each with its own parts requirements, each with its own maintenance procedures, each pulling at the already overstretched German supply chain. When a German truck broke down on the road to Moscow, the repair unit had to identify the exact make and model, locate the right parts in the right depot, transport them to the vehicle, and hope that a mechanic with experience on that specific vehicle was available. In summer, when the roads were passable and the supply chain was functioning, this was merely inefficient. In the Russian winter, when the roads were frozen mud and the supply chain was frozen along with everything else, it was catastrophic. German armored vehicles were worse. The Tiger tank is one of the most famous weapons of the Second World War. It was, in many respects, a magnificent machine. Its 88mm gun could destroy any Allied tank it encountered at ranges where Allied guns couldn't touch it. Its armor was thick enough that early Allied anti-tank weapons bounced off it. German tank crews who served in Tigers felt, with some justification, that they were operating the finest tank in the world. But the Tiger broke down constantly. Its complex transmission, designed to manage the enormous weight of the vehicle, was a masterpiece of German engineering and a maintenance nightmare. Its parts were hand-fitted. Its tolerances were extraordinary, which meant that replacements had to be manufactured to equally extraordinary tolerances. A Tiger that threw a track in the middle of combat might sit there for hours waiting for a recovery vehicle, because the parts and the expertise to fix it immediately were not available. There is a story, documented in multiple German accounts, of Tiger tanks being abandoned during the retreat from the Soviet Union not because they had been destroyed by enemy action, but because they had broken down and could not be repaired in the field, and the retreat was moving too fast to wait. Magnificent machines, left in the Russian mud, because the system that should have kept them running had been designed for a short war and was collapsing under the weight of a long one. The Americans understood something that Germany had not fully absorbed. In a long industrial war, which World War II was, from the first day to the last, the question was not which side had the best individual weapon. The question was which side could keep its weapons running. A Tiger tank that was broken down was less useful than a Sherman tank that worked. And Shermans, for all their tactical limitations, and they had real limitations that got American tankers killed in ways that are painful to read about, could be repaired, could be maintained, could have their engines pulled and replaced in the field by mechanics working from a manual, without special expertise, without custom-fitted parts, without waiting for a specialist to arrive from a depot 300 miles back. There is an account from a U.S. Army tank maintenance unit in France in the summer of 1944 that has stayed with historians of the armored war ever since. The unit's commander, a Captain James Whitfield from Tennessee, wrote a report that was matter-of-fact in the way that soldiers write when they are describing something they consider ordinary. He noted that his unit had, in a period of 3 weeks of continuous combat operations, replaced 47 tank engines. Replaced them in the field, under fire. In some cases, 3 weeks, 47 engine replacements. He noted, almost as an aside, that all 47 replacement engines had dropped in without modification. Not 43, not 38, with 9 that needed some work. 47 out of 47. He didn't seem to find this remarkable. To him, it was Tuesday again. The Germans noticed. They couldn't help but notice. German mechanics who worked on captured American vehicles in the early years of the war sent reports back to their superiors that were, in places, almost admiring in their technical assessment of what the Americans had achieved. A report from a German Army ordnance unit examining captured American trucks in North Africa in 1942 noted, with evident professional respect, that the manufacturing consistency of American military vehicles was unlike anything they had encountered in German or British equipment. The parts were, in the report's exact phrase, außergewöhnlich gleichförmig, extraordinarily uniform. The report recommended that German industry study the American approach. It was filed. It was read by several senior officers. It was not acted upon in any systematic way. The German industrial system was too complex, too deeply committed to its existing manufacturing culture, too divided among too many competing manufacturers with too many proprietary designs, to change course in the middle of a war. By 1944, the gap had become a chasm. American factories were producing vehicles at a rate that German planners could not match and components at a consistency that German manufacturing culture had not achieved. The American logistics system, built on the foundation of interchangeable parts, running on the fuel of American industrial standardization, could support an army operating across all of Western Europe in a way that German logistics increasingly could not. In the winter of 1944, during the Battle of the Bulge, American units that had been mauled by the German offensive were resupplied, re-equipped, and returned to combat in days. Replacement vehicles arrived. Replacement engines arrived. Mechanics who had never seen a particular vehicle before could maintain it because it was built to the same standards as every other vehicle of that type. The German offensive, which had begun with genuine operational brilliance and had shocked the Allied command, ran out of fuel and momentum in part because the German logistics system could not sustain it. German vehicles broke down on the roads through the Ardennes. Replacement parts that were needed were not available or were not compatible. Mechanics who might have fixed vehicles in the field couldn't, because the parts weren't interchangeable and the right components hadn't arrived. The offensive died in the snow of Belgium, and among the reasons it died was a reason that never made it into any headline and never became part of any popular history of the battle. The American trucks kept running. The German ones didn't. Back to Wilhelm Krause, in that bombed-out German repair depot in the spring of 1945. He had been a mechanic for 6 years of war. He had learned his trade in a system where skill meant knowing how to make things fit that were almost right but not quite. Where expertise meant the accumulated knowledge of a man who had worked on enough German engines to understand their individual quirks and inconsistencies. Where fixing a truck was an act of craft, of judgment, of experience. He had been good at it. He was proud of being good at it. And then he looked at an American engine in an American truck and understood that his skill, the particular kind of skill his system had required, was a solution to a problem that the Americans had simply decided not to have. They had taken the craft out of the repair process, not by making worse vehicles, but by making better manufacturing. By deciding, years before the war, that the goal was not vehicles that a skilled mechanic could fix. The goal was vehicles that anyone could fix. That a soldier with a basic course in maintenance and a copy of a field manual could keep running in a muddy field in France. It is not recorded what Wilhelm Krause said to the other men in the depot that day. It is not recorded whether he admired what he saw, or resented it or simply accepted it as one more piece of evidence that the war had been decided by forces larger than any battle. But he had stood there long enough to understand something true. The Americans had not won because their soldiers fought harder. Not because their generals were smarter. Not even because their factories were bigger, though they were. They had won, in part, because of a decision made in a Connecticut factory in 1798. Because of a principle, so unglamorous that it has no drama and no heroism and no moment where a man does something brave. The principle that every part should fit every time. And in the cold arithmetic of industrial war, that principle, carried forward through 150 years of American manufacturing into the engine bays of 1 million trucks and the turrets of 10,000 tanks, had been worth more than all the craft and skill and pride that Wilhelm Krause had spent 6 years of war putting to use. He closed the hood of the American truck, and somewhere, in a part of him that was a mechanic before it was a German soldier, he understood that it was over.